Let's do some math today. Today, we're going to talk about word problems. I know, everyone's absolute favorite topic. Now, here's the thing. Word problems require a lot of persistence, okay? So it's okay if you read it and your first thought is, I have no idea what they're asking. And so my first tip is reread it and just keep rereading it, because every time you reread it, part of the problem might be opened up to you. You might make a connection, and these things take time. So don't give up. Now, let's talk about some strategies to help us be successful. So the first thing I want to talk about is sort of our goal. Now, our goal with addressing word problems is to write an equation. And our goal here is for most of these to make like a two-step or a multi-step equation. And so if we could get something like ax plus b equals c, awesome, because that's something we can solve. And so our goal is to find a way to write an equation. Now, let's talk about some practical tips here. So when we get to word problems, one thing we need to think about is what's the difference between a coefficient and a constant? So if we were to take a look at what I just wrote there, ax plus b is equal to c, b and c are constants because these are just numbers that we're adding or subtracting, and they're part of our equation and they do not change. They stay the same. A is a coefficient. It stands next to our variable. And so as we are looking, we want to do our best to identify our coefficients versus our constants. So identify coefficients and constants. If we can do this, then what we're doing is making or helping us make the structure of the equation, because ultimately that's the goal. If we can get a two-step equation, we can solve it at this point. But in order to do that, we need to find out what's our constant and what's our coefficient. So let's take a look at some examples and work through them together. Joey was given $20 to buy 4 sodas at the movies. After buying them, he had $8 left. How much was each soda? Okay, so what I'm seeing here are 3 numbers, 20, 4, and 8. Now, of these 3 numbers, I think 2 of them are constants. I think this is a constant, and I think this is a constant. And think about this. Joey was given like a $20 bill. You can't change the value of a $20 bill. It is worth 20 bucks. Okay? So that's one of our constants. And then same thing, like after he spent money, the person gave him back $8. And so that is also a constant amount. What is sort of unknown here and what could change is this number, 4. Depending on how many sodas he bought, everything could be a little bit different. And so what I'm getting from this is that he started with 20 bucks, and then he bought some number of sodas, which cost some amount of money, and he was left with $8. And so I'm going to put 4x. All right, now this looks a little bit tricky and sneaky, but we can do it. We have a two-step equation. We're going to subtract 20 from both sides. And when I do that, I'm going to get negative 4x is equal to negative 12. Divide both sides by negative 4, and now x equals 3. So the sodas cost $3 each. And now if we kind of fact check it, 20 minus 4 times 3, which is 12, that equals 8. It makes sense. Okay, let's go to this one. At a candy shop, you bought $5 worth of fudge and 3 pounds of taffies. If you spend a total of $17, how much does 1 pound of taffy cost? Well, again, I'm seeing a handful of numbers here. And this one. A couple of them are going to be our constants, and a couple of them are going to be a coefficient. Well, actually, only one's going to be a coefficient. Again, these dollar amounts here are set in stone. We can't change those. So we've spent $5 of fudge, and then we got an additional 3 pounds of taffy for a total of $17. So again, what I'm seeing here is 5 plus something is equal to 17. Now, we want to know how much one of these costs. So odds are this is kind of giving us a hint that this has something to do with our coefficient. So 3 is our coefficient, and then x is our unknown. And that's how much the 1 pound of taffy cost. All right, well, we now have a two-step equation. We can solve it. Subtract 5. 3x is equal to 12. Divide by 3. Divide by 3. And x equals 4. And so x is a pound of taffy. And therefore, 1 pound of taffy costs $4. Box it, walk away. Okay, now let's kick things up a notch. Sally spent half of her allowance on a birthday card for her mom. Then her dad gave her $7 for doing some chores, and she had $17. How much is her allowance? Okay, so now what's going to make this tricky is that we have a number written in word form. Half. All right, we have 7 and then we have 17. So half is that right there. And again, our dollar amounts, I think these are going to be our constants. And so half of her allowance is going to be half A. And then we got to read the problem, find out, is she losing money or is she gaining money? And so it says her dad gave her money, so that's going to be adding $7. And when she had half of her allowance and the $7, she had a total of 17. So we have our equation, we can solve it. What makes this a little more difficult is that we have a fraction that we have to deal with. But just go about our business as usual. So here we have 1/2 A is equal to 10. And now to get rid of this 1/2, we're going to want to multiply by 2 on both sides. And then that gets rid of the half, and A equals 20. So her allowance is $20. Okay? All right, so these are sort of what I would call the basic equation problems. Now we're going to take a look at some harder examples. And my big tip here, I got a couple things I want to mention. The first one, let's stick with blue. Big tip is use placeholders. Placeholders are huge. They help you fill up the equation. Second, we need to know some vocab. All right, so a couple of the problems we're going to see here. We have this phrase, consecutive integers. Now, integers are integers, just jump the gun there, are positive and negative whole numbers. So something like -2, -1, 0, 1, 2, so on and so forth. So gotta know what those are. We also might want to know some geo terms. We have complementary, which means that you have two angles that add up to 90 degrees. And so we'll leave it at that. And let's take a look at some examples of these harder problems. Okay, the sum of two numbers is 21. Find both numbers if the larger is 3 less than twice the smaller. All right, so here's where placeholders comes into place. The sum of two numbers, one number plus another number, equals 21. Remember, our goal here is to set up an equation that we can solve. Now, the mistake people make is they forget to put both numbers in, because we have a neat little expression here. The larger is 3 less than twice the smaller. Well, I'm going to put an L here and an S there. Larger, smaller. We know nothing about our smaller number. It is a complete unknown. So we're going to put X there. Then let's take a look at the larger. We're told it is 3 less than twice the smaller. So twice the smaller, and then 3 less is going to be -3. Now we have our equation right here. And from this equation, we can solve it. So we have 2x, so it's 2x minus -3 plus x equals 21. Now, this is going to make it a little more complicated because we have to combine some like terms. So we'll get 3x minus 3 is equal to 21. Add 3 to both sides. So I should squeeze that in right there. Plus 3 plus 3. And we have 3x is equal to 24. Divide by 3. Divide by 3. X equals 8. Now, that is our smaller number because we said that x is equal to the smaller one. The larger one, we have two ways of finding it. We can plug this back into this little expression here, or we could just go 21 minus 8 and figure out what that has to be, and that's 13. And so we found both numbers, 8 and 13. Okay, next, let's take a look at this consecutive number problem. So the sum of 3 consecutive integers, we use our placeholders, 1, 2, 3, is equal to 72. We're going to try to find all three of them. Now here's what's tricky. Whenever we're doing consecutive numbers, we don't know which consecutive numbers we're talking about. So we're just going to say the first one is x. But let's look at a relationship between consecutive numbers. Let's just say we have 9, 10, and 11. To go from 9 to 10, we add 1. To go from 9 to 11, we add 2. We're going to borrow that idea. Our first one is x. The next one's going to be 1 more than that original one. And then the next one's going to be 2 more than the original one. And so this is the process needed to solve problems like this. And what's great is it's helping us set up some structure. So we have, now we have the equation and we can solve it. So we have 1, 2, 3 x's plus 3 is equal to 72. Subtract 3 from both sides, subtract 3 from both sides. We end up getting 3x is equal to 69. Divide by 3, and x will equal 23. Now, it said find all three of them. So 23 is our first one. That would go here. Let me do a different color here. So this is 23. This would be 24. And this would be 25. And those are our three consecutive integers. So to wrap everything up, it's all about these two ideas right here. Our goal is to write an equation, and then we have to try to identify coefficients versus constants. Good luck on your practice, and let me know if you have any questions.